Welcome to the Automated Geospatial Watershed Assessment Tool, AGWA, video series. AGWA was developed by the University of Arizona with the USDA ARS Southwest Watershed Research Center and the US EPA. AGWA is available at www.tucson.ars.ag.gov/agwa. Funding for these videos was provided by the Department of Defense Environmental Security Technology Certification Program, ESTCP. This is the 11th video in this series. Compare results from pre-fire and post-fire scenarios. This video follows the AGWA Mountain Fire tutorial. AGWA Video 2 showed how to install AGWA, how to download the tutorial and GIS data from the AGWA website, and provided some background on the mountain fire. The Mountain Fire tutorial demonstrates how to use AGWA to evaluate the hydrologic effects of land cover change, in this case from fire, using the burn severity tool and a burn severity map. You'll run AGWA with the Kinneros 2 hydrologic model before and after the fire, and then view the resulting changes to runoff, peak flow, and sediment yield. We're using AGWA version 10.7-3.9.5.2279 with ArcGIS 10.7.1 and the Introduction to AGWA for Bare Scenarios Mountain Fire tutorial version 2019. You can use any version of ArcGIS as long as you download the correct version of AGWA from the AGWA website. To compare the pre-fire and post-fire simulations, we must first import the results back into AGWA, and then we'll difference them to show the impacts from the mountain fire. Go to AGWA Tools, View Results, View Kinneros Results. In the AGWA Results form that opens, select the discretization. Click on the Simulations tab, and then we'll import the simulations. Check the boxes next to post-fire _ 10-year 1 hour and pre-fire _ 10-year 1 hour. Click the Import Update button. The boxes will turn green and the check marks will clear when the import is complete. Next, we'll difference the pre- and post-fire simulation results. Click on the Create Difference tab. Select pre-fire _ 10-year 1 hour for the base simulation and post-fire _ 10-year 1 hour for the alternative simulation. Select the change type as %. AGWA provides an optional absolute change, but this is best used only if your model is calibrated. Otherwise, use % change. Notice the equation used to create the difference, post minus pre divided by pre. Enter the new name, 10-year 1 hour post minus 10-year 1 hour pre _ PCT for %. It's important to use names that are meaningful so you'll know how the simulation was created. Click Create. Now we can view the results. Click on the View Results Map button and select the simulation you just created, 10-year 1 hour post minus 10-year 1 hour pre _ PCT. Select the units as English. Since we're calculating % change, the units are arbitrary, but we'll use English units here. Select the output, peak flow. Although this shows feet cubed per second as the units, the results will be % change. Click View. Your map will show the % change for peak flow between pre- and post-fire conditions. Darker colors and thicker lines indicate greater % change. Move the VARS feature class above the streams layer so you can see how these important locations are affected by the fire. Look at the streams layer in this table of contents. These values are the % increase in peak flow due to the mountain fire, even though the legend reads feet cubed per second. Some of the streams in the upper parts of the watershed had up to 500% increase in peak flow. You can use the Identify tool to click on the streams or plains in the map to see these values. Turn on the fire perimeter map and move it above the streams and plains layer. The burned areas in the upper portions of the watershed had the greatest percent change, while the areas outside of the mountain fire had little change. You can also see that the areas furthest downstream from the fire also had little change. View the percent change results for runoff by changing the output to runoff. The moderate and high burn severity areas had over 100% increases in runoff in the streams and over 700% increases from the plains. The percent change for sediment yield shows similar results. View the values in the table of contents to see the increases in sediment yield in the streams and plains due to the mountain fire. Agua also provides hydrographs from the simulations. Go to Agua Tools, View Results, View Kinneros Results, and then click on the View Results Hydrograph button. Check the boxes for the simulations, post-fire _ 10 year 1 hour, and pre-fire _ 10 year 1 hour. Select Streams for the elements, and use the Select Features button again to draw a rectangle around the stream reach at the watershed outlet. This is the road culvert VAR. Select English for the units. Select the output as outflow feet cubed per second, and then click View. The hydrograph appears. The blue line is the pre-fire hydrograph, and the red line is post-fire. But because the model was not calibrated, we look at the relative difference between the two. You can change the colors of the hydrographs by double-clicking on the line. View the hydrograph at the Forest Service boundary. This is one of the VARs, so move the VARs layer above the streams so it is visible. Use the Select Features button again to draw a rectangle around the stream reach directly upstream from the Forest Service boundary point, the leftmost VAR. Select Metric for the units. Select the output as outflow, meters cubed per second, and click View. Compare the hydrographs at the watershed outlet and at the Forest Service boundary for peak flow. Note that the scales on the two graphs are very different. Also remember that we're looking at relative change, not absolute values. The blue hydrographs are pre-fire, the red are post-fire. Peak flow at the watershed outlet was larger than at the Forest Service boundary, but percent change was greater at the Forest Service boundary. This is because the contributing area at the watershed outlet is much larger than at the Forest Service boundary, and most of the lower watershed was unburned, while all of the upper watershed was burned. We can clearly see the influence of the mountain fire on peak flow, even for the low to moderately burned areas. Agua also provides tabular results that you can export to your workspace folder. Click on Export Tabular Results. Select both simulations to get the results for both. Select Streams for the elements. Then use the Select tool to click on the stream reach at the watershed outlet to export these results. You'll select the Forest Service boundary separately. Select English for the units, then select All Outputs. Select your workspace to export the CSV file and click Export. You can open this file and calculate the percent change as post-fire minus pre-fire divided by pre-fire times 100. Repeat these steps for the stream reach at the Forest Service boundary. We can see that the percent changes were greater at the boundary than at the outlet, as we saw previously in the hydrographs. This information can help guide management decision-making and reduce mitigation costs. The next videos will show how to obtain the data needed to run agua. Video 12A will focus on the DEM data, soils, and land cover data. Video 12B will show how to obtain the precipitation data to run SWOT.